Good. All right. So let's see. We last time we did 11A. Do you guys have any questions on so far? Any questions so far? No? No questions? Okay. If you don't have any questions today, I'd like to move forward to alpha 12. Okay, to alpha 12. 11A, B, C, D. I think we have several, a couple set of questions, but you're only required to do A. Okay, it's optional to do, B, C. Okay, it's optional to do B, C. So let's move on to alpha 12. Okay, alpha 12. You guys there? Alpha 12. Alpha 12 is another kind of if statement. Okay, so I'm going to give you the different perspective for it. Okay, because these kind of questions but this time it's if statement, right? Solve each inequality instead of instead of having equation, instead of have equal sign, we have inequality. Okay, and we also want the solution to be in specific forms. We also want the solutions to be in specific forms. Okay, so let's take the first one for example. Okay, take the first one for example. Right here, we have absolute value of x less than 3. What does it mean? Understanding the meaning is very, very important. It's very, very important. Okay, so I'm going to give you two perspectives. I'm going to give you two perspectives understanding this. Okay, what does it mean that the absolute value of x is less than 3? Okay, you might have learned a way before. Okay, so I'm going to give you the function perspective. The function perspective. Okay, we talk about that absolute value is a function. Okay, and this statement basically is a big if statement. First of all, it's a big if statement. Okay, it's an if statement. It's that if, okay, the absolute value of a number, okay, the absolute value of a number is less than 3. Is less than 3. What could the number be? What could the number x be? Okay, in this case, actually the answer is not unique. You have many, many solutions. For example, if x equals to 0, the absolute value of 0 less than 3, that's true. If x equals 2, absolute value of 2 less than 3, that's also true. If x equals -5, whoops, that's not true. Absolute value of -5 is +5. That's not true. And so if you start to think about all the possible numbers that x can be, okay, think about all the possible numbers that x can be to make a true statement. To make a true statement, right? To make a true statement for this inequality. And we realize there are many numbers. There are many, many such numbers. So the question is there, because every such number will make part of the solution. Every such number will make part of the solution. Okay. every such number will make a part of the solution. So we want to include all of them. Okay, so we have many. Obviously, we have many, right? Because I only enumerated like 0 to -2, and so on and so forth. So how about the numbers in between them? Those decimals of fractions, irrational numbers, and of course, there are many, many of them, right? If 2 is a solution, 2.5 is a solution, 2.333 is a solution, 2.78 is a solution. And you can keep the list going on. So there are many, many solutions, right? So we realize, okay, we realize there are many, many solutions to this inequality. Now the question is, how do we find those solutions systematically? Right, that's the question. How do we find all of them systematically? And how can we summarize them in a simple mathematical expression, if possible at all? Right? So there's the first perspective I like to give you is really the function perspective. It's really the function perspective, because we know that the absolute value of x is a rule, right? We know this is a rule. This is a rule, right? This rule takes the input, and of course our input is x. It produces output, okay? And the output, of course, we want the output less than 3. Okay, we want the output to be less than 3. Okay, we want output less than 3. So basically it says if the output of absolute value of x is less than 3, that's what it means. So we got another perspective. Right? We know this picture. We certainly know this picture, right? How does the picture look like? That's how it looks like, right? We're pretty familiar with the function. And what are the input? What are the input? The input are, right? The input are the numbers on the number line, because we know the domain is all real numbers and the range is greater than or equal to 0, right? So we know the domain of this, absolute value function, and you can call it f if you want. Well, you don't have to. You really don't have to introduce this. It's just to be, to be connected with what we did before, right? For the function, that's as a function, as a rule. And where do we find the input? Say if you have any point, for any point on the curve, on the curve, we call it a curve, there's an input, and there's an output. And now we want the output to be less than 3. Now we want output less than 3. We want output less than 3. Where do we find those output that are less than 3? Well, we can see that where do we find all the output? Right? So if I graph this line, okay, for this point, the input is this much. Okay, this is the input. Right? That's the input. And what's the output? The output is this height. So we want the height to be less than 3. We want the output to be less than 3. Do you guys follow me? We want the output to be less than 3. So what are those? And then, so this question becomes, if I want all the possible input, such that the output is less than 3. So where do we find those inputs? Well, this point, the output is less than 3 because this line, this horizontal line, that output is 3. So anything less than 3. So you have all of these points on the curve, right? All these heights are less than 3. Do you follow me? All these heights are less than 3, including this one, right? This dot. All these output are less than 3. So in the end, what have we discovered? Right here, right? Between -3 and 3. Between -3 and 3. Between -3 and +3. So we discovered that there's a dot here, or circle. There should be a circle. So this point, which is 3, a -3, and this point is a +3. In between all of these input, will give us less than 3 output. You follow me? Input, output. So all of these numbers. Okay, so let me clean this up. So between -3 and +3, here this is a -3. Okay, so I'm going to show the -3 to you. Okay, by just let's see if I can make this adjustment. Do you guys follow me? Does everybody follow me? I'm going to make it -4 to see if this will make it. I just want to show the picture a little bit better. Okay, so 1, 1, there. That still doesn't make it. But anyway, this is a -3, this is a +3, right? That's a -3, and there's a +3. So, and these 2 points are going to be circled. Okay, so what it means, that you're going to have 2 points on the input. Okay, so it's a -3, 0. And this is going to be red dot and circled. Okay, and there's another one, and there's going to be another red dot circled. So all the points in between, okay, so what are all the points in between? All the points in between, which are here, okay, so all of these points, okay, I'm going to put the dots right there to see if it shows me. Wait. There, line, and make it thicker. Every point, which is the input here. So see, you can see for this input, right? You can see for this input, the output is going to be this high. Is it less than 3? And the answer is yes. Therefore, this point, whatever it is, it looks like it's between 0 and 2, between 1 and 2, 1 point something, and that is going to be a solution. By the same token, okay, we run all the points between -3 and +3. Every single input will produce output less than 3. So that's what we want. Another output that's less than 3. Do you guys follow me? I'm interpreting the meaning. We want all the input such that the output is less than 3. So we have many such dots, and all of these dots is between -3 and +3. Okay, so let me mark it here. Okay, so this is -3, and over here, and this is a +3. So all the points between -3 and +3, and those are the solutions. Those are the solutions. Now, how do we express it? How do we express it? Any questions? Do you guys understand the meaning? Any questions? Do you understand the meaning? Okay, from this functions perspective, input, output. So what are all the input to produce the output as required? And the output required is what? The height, okay, is the output, the height, okay? All of these heights are the outputs. All of these heights are the outputs. And we want all of these heights less than the red line, okay? Less than the red line, okay? Less than red line, so that has to be negative between -3 to +3. Okay, so that's the function perspective. So now, can you tell me what are the solutions? The solution is about input, right? We know output. We were looking for input. And if the output be less than 3, the input should be where? The input should be between -3 and +3, which is right here, which is just like what we graphed. Does not include a -3, +3. Does not include a -3, +3. And of course, I'm sure you're asking, how much work do I need to show? If you understand this context, if you understand all this context, okay, so I'm going to show you a version of how to show your work. Okay, you'll be amazed as how short it is. Okay, show work. Okay, solve this inequality. How much work do you need to show? The answer is -3 less than x less than 3. You're done. You're done. That's all. Okay, so this might be consistent with what we have learned before. This is just one perspective. This is just one perspective. But by this time, we're done with this question, where I will show you another perspective, which might have been something you learned before. Okay, let's see if it will ring a bell. Okay, let's see if it will ring a bell. Okay, another approach. Another approach is not looking at this as a function. We look at this, this picture, we just look at this as a number line. Okay, so instead of, we don't see it as a function. Instead, I'm just going to see this as I'm going to make this as a I'm just seeing this as a number line. Come on. Come on. Oh, I need to make some adjustment. Sorry, I need to make some adjustment. Okay. Come on. Yeah. We just treat this as a number line. Hold on. I need to cut off some stuff. Okay, with that, I'm gonna get rid of that stuff. Okay, so I'm gonna delete those, delete that. Just that's it. That's all I'm gonna leave. So you just look at this number line. Okay, you don't even need to look at those vertical part. Just look at from the number lines perspective. Okay, what are the numbers on the number line? What are the numbers on number line, right? Such that the absolute value of those numbers, right, is still an if statement, right? If the absolute value, so you're talking about the distance, we're talking about the distance between any number, okay? We're talking about numbers from here, there, and their distance to 0. Their distance to 0 They're all less than 3. So where do you find those numbers? Of course, you're going to find your numbers all here. All of these are solutions, right? All of these are solutions because every one of them has a distance to the origin, which is less than 3. You follow me? So this is the horizontal line you probably have seen before. Okay, this is a horizontal line you probably have seen before. Okay, and then you just have to write it, express it properly. You just have to express it properly. Okay, do you guys see those little circles over there at the end of this red line? You guys see those little circles? Yeah. Okay, so let me make it just a little bit more visible. Is that better? Is that better? Okay, so to show work, if you have learned it this way, okay, understanding the question, so your answer, the way you show your answer is still the same. Show work. Does everybody follow me? But I want you to understand this. This is, even though as simple as it is now, it is very, very critical. It is very, very critical from 2 different perspectives. One is a function perspective, and the other one is just on the number line, just number line. Does everybody follow me? Okay. Now, okay. Let's look at number 2. Number 2, instead of less than 3, it says less than or equal to 3. Less than or equal to 3. Less than or equal to 3. If it's less than or equal to 3, if we talk about from the function's perspective, right? By the way, you only need to show this much work to me, okay? You only need to show this much work to me for the previous question, number 1, okay? You don't need to show more. But you need to understand all of these perspectives because we're going to use it very often, very often. Okay, so now the picture will have to be changed, right? Because right now it's no longer, it's a solid line for the output because it can be equals to 3. So these 2 circles, they're no longer a circle, they're going to be dots. Okay, and the idea is the same. What are those output? I'm sorry, what are those input such that the output is less than or equal to 3? So what are they, right? So for this input, right, and the output is less than 3, less than or equal to 3. It could be equal. And for -3 will also be an answer. -3 will also be an answer, right? So if it's -3, then the output would be precisely this height, 3 exactly. So in this case, the solution, which the output is less than or equal to 3, the solution will be everything between -3 to +3, inclusive. Inclusive. Does everybody understand? Okay, so we're explaining the meanings. So now, how do you show the work? How do you show the work? Well, this is how you show work. Okay, the solution will be -3 less than equals to x less than equals to +3. That's all the work you need to show. You don't even need to bring the picture, but if you want to, you can. Okay. And some of you might be asking, well, what if I give you the interval solution? What if I give you the interval solution? Okay, so I'm going to answer that question. Interval solution. okay? The interval solution here will be -3 to +3. I would, if you give this interval solution, I will acknowledge your interval solution is correct, but you're not getting any point. You're getting point for that solution. Follow me? You're getting points for that solution. And how many points you get? You're usually going to get 2 points or 3 points. 2 or 3 points. Depends. Depends on how the questions are being asked. Do you follow me? Then you say, well, the interval solution doesn't count because I know everyone knows how to do the interval solution. Okay, I know pretty much from my experience, everyone know the interval solution. Therefore, you know, I acknowledge the correctness, but you're not getting points for it. Okay, this is to work for the effort, you know, for my part, to encourage you guys to be better at inequality. Inequality is a major difficult part for our students across the you know, nation boundaries. Okay, it's international problem. Okay, it's internationally college students have a hard time handling inequalities. Intervals, no problem, no problem. Okay, so we need to work on that. We need to work on how to handle inequalities. Understood? If I give points for these, I give point to everyone. Okay, same number of points. I don't give points to anyone, and nobody get a point for that. Got it? You still need to recognize it. Okay, on the quizzes, you might get points for those. Okay, but you have to be able to recognize other ways of solution. So far, so good. So let's look at another perspective. Another perspective for this question would be that if you do the number line, okay, to solve this equation, okay, if you see it from the number lines perspective, of course, the answer is the same. The way you show the answer is the same. And I just have to, you know, I'm going to show you the other version, because this time you're going to have dots. Okay, now that's a dot. There, that's a dot. There's another dot. 2 dots. The other question is, will your picture get points? Will your picture get points? Oh, I'm sorry. I'm sorry, guys. Okay, I'm gonna make it right. This software is a kind of erratic on these things. Okay, so let's see. I need to make adjustment on these pictures. Okay, so we got the dot. Okay, so we get the dot. I'm gonna get rid of those, you know, vertical marking. But anyway, so will the picture count for any point? The picture will not account for any point. Okay, I give all the points to this inequality. I gave all the points to the inequality. You can still feel free to draw the picture if I ask you to do the written test or something. But this correct picture will not get you point. It should serve as a guideline. It should serve as a guideline for you to make that inequality. Is that clear, guys? Is that clear, guys? Any questions? Okay, I just want to make it clear. Okay, we have a focus here, and the focus is a very tough, you know, topics of using inequality, which is very tough for a lot of our students. Okay, so we're going to keep our focus on there. Okay, so do you think you're ready to try one? Are you ready to try one? So alpha 12A, alpha 12A. Okay, so alpha 12A. Okay, I want you to reflect on these meanings which we addressed. Okay, it's an if statement, but we have addressed these different perspectives. The function perspective, right? The function perspective here, and here we want to less than or equal to 3, right? So this time is less than or equal to 3, less than or equal to 3, right? So all of these meanings considered, I want you guys to choose, okay, any 3 questions. You choose any 3 questions, okay? They look hard to you. They look hard to you, and you work on them. You work on them, okay? And I'm here. I'm here. I'm gonna just get a little something to drink. I'm around. I'm here. I got a shot yesterday. I got the vaccine shot, the first shot yesterday. The shoulder feels sore. I hope you guys get it too soon. Choose any 3 questions. Any 3 questions. Oh, good. Your dad got a shot. Have you got a shot? Anybody in this class get a shot besides myself? Not yet. Okay. I think your turn will come soon. The site the site that administrating the shots is very orderly. It's very well organized. I was very impressed. We didn't have to wait in line, so we basically got there, you know, get into a short line, and we got our shots. And after the shots, we waited for 15 minutes, and we're okay. I would say I experienced a little bit, you know, I feel sore on in my arm, and I also have a little bit headache for very shortly. Didn't last very long. Other than that, so far so good. Do I sound like pretty coherent so far? Am I coherent for you? Okay, thank you. All right. So get your shots if you want when your time has come. Now, shall we compare notes? Let's see. Okay, you can start asking your questions now. Okay, you can start asking your questions now. I'll make it 120%. Anybody has trouble reading these notations, reading these signs? I notice, I know some people, okay, at least some of my students in the past, they have trouble understanding these notations. They have trouble understanding these notations. So I'm gonna, can you guys give me a second? Okay, understanding the notation. Understand notation. Notation. Okay, for example, you see this notation, right? And you also see this other notation. You understand the equal, right? Turn this way, turn that. It really doesn't matter because the smaller number on this side is always smaller. On this side is always larger. Okay, and the same thing. The opening side is always larger than the pointed side. Okay, so it doesn't matter which direction it goes. It doesn't matter which direction it goes. You just have to understand its meaning. So it always indicates the opening side, the opening here. This side, the quantity on this side is larger than the other side. So you will read it that, you know, something less than something else. And this one will be something larger than something else. Okay. All right. So let's see. Do we have any questions? How are you doing? How are you doing? Choose 3. Don't try to get those decimal numbers. Just work with root 2, root 3 over 2. Okay, just work with root 3 over 2. If you want to know how big it is, you just estimate it. Okay, but you just work with that number. Okay, we prefer you work with the precise number. You probably would notice that all of you math professors, they like to have, they like to handle precise number. They don't like to handle those decimal numbers. If you have any questions, it's time you can ask now. Okay. Do take your time to work on it. Okay, do take your time to work on it. This may not be what you picked, but I'm just going to put this. I assume that some of you may want to know the answer. Okay. So from two different perspectives. Okay. I think I'm going to make a table to put these together. Okay, just do whatever you do, okay? Maybe I should put a table to explain these different perspectives. One is a function perspective. And that's the number line perspective. Function perspective involves that if the output is less than 3. And this one just it's just like it's just if that absolute value, the outcome of that, if they both if statement. Okay, so I'm putting these together for us to do the comparison. Okay, so and solution. Okay, it's -3 less than x less than 3. And the same thing, solution are the same. Okay, we have pictures, so we have all of these things to refer to help our understanding. Okay. The next one, okay, keep doing what you're doing. Okay, the next one, to summarize. Okay, I'm going to replace this picture by that. Okay, I'm going to replace that picture. Just that. And of course, this is less than or equal. So make sure that there's some minor changes required. Less than or equal to. Three. So less than or equal to 3. Less than equal to. Okay, so in terms of showing work, it's very straightforward. They are consistent, but it's just different perspective. Okay, so now for square root of 2. Square root of 2. Let's see what has changed. Right? For square root of 2, what has changed? Right? So now we change to square root of 2. So this will change to square root of 2. Do you guys follow me? Do you see they're really the same model? They're really the same mode. They're really in the same mode. And the nature of the questions are really the same. The nature of the questions are really the same. And this just going to be square root of 2, and this is going to be square root of 2. And of course, here I need to make some adjustment on my picture, right? So this is going to be square root of 2. And I'm going to make this will be the square root of 2. And this will be square root of 2. It's really this, it seems that the scale has changed, right? The scale has changed. And one last thing I need to do. And this changed to square root of 2, and this is changed to square root of 2. And then I'm all set. Right? So it's just a scale a little bit. What is square root of 2? Square root of 2 is about 1.414 something. It's a number between 1 and 2. Okay? You don't have to worry about it. What is it exactly? You will never know what is this exactly. The exact number for square root of 2 is square root of 2. You follow me? The exact number for square root of 2 is square root of 2. Okay, so on this perspective, okay, I'm just going to make a little bit of adjustment. Okay, so let me do it again. Square root of 2. Okay, square root of 2. This is really just change of number on my part. And when you graphed it, you can see all the important elements of that has not changed. Okay, less than square root of 2. And just these numbers have changed to square root of 2. You guys with me? If square root 2 really bother you, I hope it doesn't bother you anymore. I hope it doesn't bother you anymore. Okay, so now that was number 3. I had a, I just took the liberty to do number 3. What question do you guys have? You wish me to go over? What other question you want me to go over? 4, 5, 6, 7, 8. Anyone? You can ask your questions on chat, private or public. All questions are welcome. All questions are welcomed. Yes? No? Hello, are you guys there? Any question? Any question? No question. All right, you got them all? Okay, if you don't have any questions, I'm going to check on you. Now, number 4. What is your solution for number 4? What is your solution for number 4? You can see show work is pretty straightforward. It's easy, right? You understand the concept, you understand the 2 perspective, and the answer is pretty straightforward. Now, what are the solutions for number 4?
Just 0.
That's right. Very good answer. Very good answer. Very, very good. Okay, because the absolute value of x cannot be negative, and you want it to be less than or equal to 0. It cannot be less than 0. Therefore, the only way for this to be true is it's 0. Very good. Okay, so the solution is x equals 0. You're done. Excellent. Any questions on this? Any questions, other people? Ellen? Stephen? Francesco?
No question.
Everybody, you got it? All right. How about number 5? How about number 5? Absolute value of a number is less than 0. Two different perspectives. Two different perspectives. You want that absolute value of a number less than 0.
No solution.
Perfect. Wonderful. Perfect. Did everybody get that? Okay, perfect solution. Oh, okay. The solution is, the answer is, the solution is no solution. Because no number will make it happen. No number will make it true. Okay. The height, right? You can see those height is always going to be above 0 or equal to 0. It will never be beneath 0. You don't see any height beneath 0. There's no such input will make that happen. On this side, it's even more so, right? It's just the same concept, the same concept. Now, how about number 7? What's your solution for number 7? Solution to number 7. Guys.
No solution.
That's right. Perfect. Perfect. I think you got it. I think all of you guys got it. Could I say that? Could I say that? All of you got it. All right. So we're going to pass alpha 12A and we're going to move on to alpha 13. I'm going to move to alpha 13. Are you guys there? Alpha 13. Alpha 13. Alpha 13 is similar to what we did with alpha 11. Okay, it's still if statement, but you just regard that. Then you, so for example, right? We just did alpha 12. In alpha 12, we had a situation of absolute value. Okay, if the absolute value is less than 3. Right? So how do we do that? Right? We regard it as, you know, we know how to handle absolute value of x less than 3. Okay, and we know the answer is what? Is between -3 and 3. We know all the, we know everything about it. And now it turned, if you look at number 3 on alpha 13, you have absolute value of x minus 3 less than 2. We treat this as something we call baloney. And of course, now the baloney is x minus 3. So we know how to solve that, right? So that baloney is going to be larger than -2, smaller than 2, right? With all the pictures to compensate. And now the baloney happened to be x minus 3. So what do you do? So this is going to be x minus 3. You follow me? So it's really the same mode, and one more row. And we just have to isolate the x. How do we isolate the x? We're going to add 3 on every side. We have 3 sides. Add 3, add 3, add 3. So we're going to take this guy Because if that is true, we add a 3 on all sides, it will still be true. And so in the end, we get x larger than 1, smaller than 5, smaller than 5. Do you follow me? Do you see the analogy? Do you guys see the analogy? Does everybody see the analogy? Okay, now the question is, how do we show work? How do we show work? Show work. Okay, in this part of the work, I will ask you guys to do some written quizzes. Besides the quizzes with multiple choice, I will also ask you guys to do some written quizzes. Okay. So now, how do I show work for this guy? Right? What do I expect to see? What do I want to see? I want to see the second step is like this. Right? It's if then kind of reading, right? If this is true, then this is true. And if this is true, then that is true. You only just have to show these 3 lines. That's all. Okay, do you need to show this line? No, you don't really need to show that line. You can if you want, but make sure you show it correctly. Okay, so you can see they all come from the same mode. The same mode. You guys want to try some? Okay, I'm going to do one more before you try. Okay, the next mode is absolute value of x less than or equal to -3. And now we change it to something like this. Okay, omega or bologna, okay, is less than or equals to square root of 3, for example. Okay, I'm looking at the number 4. I'm looking at the number 4 on alpha 13. Do you guys follow me? And that means the omega is going to be greater than or equals to negative of square root of 3, or and less than or equals to square root of 3. Now, when the omega is x minus 3, so this is going to turn into x minus 3. Okay, and next we just have to isolate the x by adding every side by 3. Okay, so we're going to add every side by 3. Okay, so let me move this down a little bit. Okay, move this down a little bit. Okay, so we're going to use this model. You're so familiar with it, right? So x minus 3 less than or equals root 3, and then we have this setup because this would be considered the bologna, right? So let me use this as a bologna. How about that? So how about we just introduce bologna here anyway? Could you guys follow me? Could you guys follow me? Is this fine? Everybody? Yes? Do you see that model? Right? So we're going to add a 3 on every side. We're going to add a 3 on every side. We're going to add a 3 on every side. So in the end, you see x is isolated. Okay, x is greater than that. Okay, so negative root 3 plus 3, you can just copy that and put it here. And the root 3 plus 3, that's fine. And that's less than or equal to. You see the analogy? Do you see the analogy? Yeah, that's how you do it. That's how you do it. Okay, so for the remaining of the for the remaining of those questions, okay, for the remaining of the questions, I want you guys to try it. I want you guys to try some. Okay, so this is how much work you need to show, and for the next one, okay, so show work for solve solving this guy. Okay, how much work we need to show solving that guy, right? And all you have to do is that we already showed partially the work, but you can make it even shorter. Okay, you get to this step. Okay, and the last line. That's all you need to do. That's really all you need to do. And the other line that I skipped is optional. It's optional. So that's all the work you need to show. You follow me? Okay, so now please pick 3 questions from Alpha 13. Okay, I'm asking you to pick 3 hard questions that appear to you, hard to you. Some of them may appear hard to you, but after you do it, it's really not that hard. So, okay, please pick 3 questions from Alpha 13 and do them. Okay, so let me, so these are the work you need to show. Okay, if you show these kind of work, it's amazing. It's amazing. And you will impress every professor you're going to see in 4-year school and on campus at El Camino. I promise you, if you can show this kind of work, everybody who grades your work will be very impressed. Okay? So please pick 3 hard questions to you from Alpha 13 and work on them. Has it become easier? Has it become easier? And the next quiz I will be giving you will be a written quiz. Okay, so it should be coming up either today or tomorrow. Okay, I'll try to make it today. Everybody did well on the quizzes so far, right? Yes? No? If you have any questions, please don't hesitate to ask. Please don't hesitate to ask. Okay. Shall we try one? Do you have any questions so far? Do you have a question when you're trying those? Please ask your question now. All right. Is everything easy for you? Is everything easy for you? No question. All right. So I assume there's no question then. But please do get your question to me if you have any, okay? And next we're gonna get to alpha 14A. Okay, 14A. And you will see there's a slight difference here. This time is larger than. This time is larger than. So before we do that, I think we should probably take a break. Okay, so let's take a break for 10 minutes. Okay, so back at 11:50 a.m. Okay, so we're gonna come back at 11:50 and I'll see you there. Okay, I'll see you soon. Okay, so let's look at 14A. Okay, you can see this time the story has changed a little bit, right? The story has changed a little bit. The first question says the absolute value of x, we want it to be larger than 3 instead of smaller than 3. And what is that implication? What is that implication? Okay, so there's still two perspectives. Okay, two perspectives. But this time we want the output larger than 3. We want the output larger than 3, right? What we did before, those are smaller than 3. So now we want it to be larger than 3. So if these 2 points are -3, +3 here, and we want these are the inputs. So these inputs will make the output larger than 3. So we want this height to be larger than 3. So this line, this broken line is larger than 3. So all of these inputs here, output, input here, outputs. So we have many. Some of them are less than -3. Some of them are larger than +3. Okay, so did you guys draw that picture? Okay, so I'm going to do some marking here. Okay, just to show. Okay, so that's going to be 5, 2, 3 at the level of -8, and that's a 3. See if that will make it. Yes, y is 3. So this is we want the height to be larger than 3. Okay, and this level is the 3. Okay, we want to be larger than 3. So all of these inputs, okay, so all of these inputs will give larger than 3 outputs. So all of these are solutions. All of these are solutions. Okay, on the number line perspective, the same thing. All of these numbers will give us the solutions. Not including -3, not including +3 either. Okay, so the question is, how do we express it in inequality? We know there are many solutions. We understand that, right? But how do we express it? Okay, how do we express it? Okay, this is how we express it. On these numbers, for these numbers, okay, so you can see all of these numbers, they're all less than -3. Okay, so let me mark that -3 to see if I can mark it real quick. Okay. And quantity, this is a -3. So I'm going to put this as -3. Beneath it, -0.2. And mark it as -3. I'm going to put a red right there. Oh, it just doesn't show very well. Okay, just -3. Let me make it just a little bit lower. I will make it -3. Okay, thank God. Okay, so all these numbers that are, do you guys see that clearly? Do you guys see those clearly? When I make the picture larger, it just it gets messed up. Okay, so this point in -3, and there's a +3 here. So let me mark the +3. Okay, I need to mark it because I want to set the example for you. So this is going to be 3, and this is going to be -0.5. Never mind what I said because I was just using this software to make it work well for us. That's what I'm trying to do. That's a +3. So this is a +3. This is -3. All the solutions. Okay, so this part is very tricky. Okay, because we see all kind of mistakes in this regard. Okay, all of these numbers are solutions. All of our students know how to mark these intervals. All of you know how to mark the intervals, I believe. Am I right? Now, but when it comes to express this interval in inequality, that's where we have the problem. Okay, so this piece of interval will be expressed as x less than -3. Okay, and this other piece will be expressed as x larger than 3. You can see these two categories do not overlap, and in between them should be separate, connected by or. Okay, so this is the interval. This is the inequality way of expressing our solutions. Okay, so these input will cause the output to be larger than 3. Okay, x is less than -3, all of these numbers, or x is larger than 3. Do you guys follow me? So please do write it down because I'm going to write it down in the table. Okay, so it moved. Okay, it moved. All right, so these numbers, so the solution to that inequality, absolute value of x larger than 3, is this: x less than -3 or x larger than 3. To get full credit, you have to have this entirely in your work. Does everybody follow me? And for the other one, same thing. For the other one, is the same thing. So you can see it's all about input. What input will cause the output to be larger than 3? And those inputs are, okay, so I'm going to mark it one more time. These numbers or that numbers. Okay, you have to use the word or, not and. If you use and, that's an empty set. And it's impossible. Okay, if you use the word and, you cannot be -3, smaller than -3 and larger than 3 at the same time. Do we agree? We cannot use and, it has to be or. So I'm going to give you a written version of a correct answer. Okay, I'm going to give you a written version of a correct answer. I want you to, I want you to write these down on your paper. Okay, I will give you a written version, a short version of how the answer should be presented to get you full credit. Are you ready? You're done with the marking. You're done with the marking. Let me check that. Okay, it's me recording. Are you done with the marking? Okay. So how much work do you need to show? Okay. This is how much understanding you need to have. This is how much understanding you need to have. So how much work need to be shown? How much work need to be shown? Ready? All right. Okay, my red line is sufficient to show the work actually. Okay, now suppose you ask to solve for, okay, show work. Okay, show work. Okay, no confusion, solving for x. Okay, and the inequality is like this. X is larger than 3. The work you need to show to solve this one is just x is less than -3 or x is larger than 3. How many points you're gonna get? 1 point, another 1 point, another 1 point, 3 points. 没有吗？
还没上。
我在上课呢。你在上上？我在给他们打 type。Okay, sorry. I'm. Someone thought I'm. 3 points. 3 points. Okay. Every piece counts. Then you say, what if I'm missing? If you're missing the or, okay, you can see if you understand everything, this is how you show your work. If you say, oh, I'm going to separate by a comma, then you don't have 2 points. Then this is the time I need to decide that you're going to get 0 point or 2 points. Okay, I will have to decide. I decide from your context. If from your context, I realize you don't understand the difference between and, you don't understand the difference between and or, you're going to get 0 point. If from your context, I decided you understand the difference between and or, you're going to get 2 points. You can see or takes a point. This or must be there absolutely. If it's missing, it could cause all kinds of problems. Okay, whoever grade your work could interpret it as does he understand this? Does he understand the difference between and or? Definitely cannot use and here. Okay, okay. So 2 points or 0 point, not sure. Okay, what if someone put the answer as and? In this case, surely you're going to get 0 point, no point. Okay, because it cannot be and. And cannot happen. That's an empty set. Okay. So popular mistakes. Popular mistakes. This is one of the mistakes. And this is the second mistake I see very often. Okay. You see, this is how much work you really need to show. This is really how much work you need to show. Okay, provided you understand the pictures, the interpretations, the if statement, and so on and so forth. Okay, now there's a third one. The third mistake, which I see very, very often, is the student would write x larger than 3, -3, larger. For this mistake, you are going to get a 0 point. Why? Why? This is the all-time favorite mistake. When I was a TA in graduate school, I saw this mistake. Okay. At the time I was at USC attending graduate school, I saw this mistake. And sure enough, I've seen this mistake many, many times over and over again. It seems that the student combine these two. No, you cannot combine these two because it's or. When you combine these two like this, you have to understand how it's being interpreted. Okay, the interpretation. Okay, The interpretation, interpretation, you're telling the reader, the solution is numbers, or is any number. You can say what, whatever, is any number x such that any number x that is greater than 3 and smaller than -3. You guys follow me? That's the interpretation. No matter what you wish for, okay? Then you can say, hey, I this expression I wrote down here, I meant this. That's what I meant. But no, your grammar is not the mathematical grammar. Okay? We don't interpret that way. We interpret it this way. This is our interpretation. Your solution is any number that is greater than 3 and smaller than -3. If you read out aloud, can you tell me, does such a number exist? Is there a number that is larger than 3 and at the same time smaller than -3? Does such a number exist? Could you guys say something? Does such a number exist for you? And then you say, well, can our math professor interpret the way I intended? It's in my mind. Well, sorry, no, never. It's never gonna happen. Anytime that for solving, inequalities like this, you write it this way, you always get 0. You always get 0, no matter what your intention is. No matter what your intention is. I'm sorry. You have to write it this way. There's no other way. There's no other way. Do you follow me? Of course, you can write interval, but I told you interval doesn't count for points. You can be correct with interval solution, but interval solution doesn't get you the point. You must write it this way. Do you follow me? I saw this mistake over and over again for the past, oh my God, how many years? Since 92, almost 30 years. I've seen these mistakes over and over and over again. Do you think I might be able to eradicate this mistake? I certainly hope so. I make this effort. Okay, that's why I pointed out this mistake. Are there other kinds of mistakes possible? Okay, are there other kinds of mistakes? Surely. But this is being the top. This is the top mistake. This top the chart with the highest frequency. Then the question is, why could you do that? Why? Then the other question is why, right? Why for solving inequalities of x less than 3, I can write -3 less than x less than 3. Whenever you write it this way, it always meant and. So what is the interpretation here? What is the interpretation here? This interpretation here is the solution. Okay, the solution is any number that is greater than -3 and smaller than or less than or smaller than +3. You guys follow me? So whenever you put these inequality signs in this kind of form, or in that kind of form. It only means and. It always means and. So you can see the consistency in mathematics. It's not going to change because any one of us want to be that way. Do you follow me? So just don't do it. Just don't do it, please. Whether you're here at El Camino or you go to four-year schools. So please don't do it. Okay. It's a terrible mistake I've seen so often. I see so often. Okay. All right. There might be other mistakes, and if I see more, I will point it out. Okay. I'll point it out. The other mistake I see, it could be something like this. Okay. It's certainly the wrong answer. Okay. Let me try this. A student might write this. Sometimes I see this. Sometimes I see this. When you put them in this kind of connection, they should always go in this point to the same direction. They don't point to the wrong, the different direction. They don't point to the opposite direction. Okay, so never ever do this. Okay, there's no such a thing. There's no such a thing. 0 point. Is that clear, everybody? Popular mistakes. Is that clear, everybody? Is that clear, everybody? These are the mistakes I have seen. Okay, whenever you write these in, you know, like a chain, right? If you when you write it in chain, it always interpreted as and. It's always interpreted as and when you write it in chain. This is correct. This is going to get you 3 points in this context. But this is going to get you 0 point. Okay, it's very frustrating for me. Okay, and of course, most of us probably get used to it because we expect this kind of mistake to show up. But I really don't want that to happen to you. I really don't want that to happen to you. Okay, so it's your turn. Oh no, wait, greater than equal, right? Greater than equal case. So we did the first one for number 1, for 14A. So let's look at for what if we change it to greater than or equal to, right? So this is going to be number 2. What I want to show you, not only it will save me some time doing the graph, I also want to show this. I want to show you this similarity. I really want to show you the similarity. What if this change to greater than from greater than to greater than or equal to? What will happen? Well, all of these will become dots. All of these will become dots, right? So I'm going to change them into dots. Okay. And this is going to be a dot, right? These are going to be a dot. And what else? And that's going to be a straight line. It's no longer a broken line. It becomes a dot, right? So how your solution will be looking like? Greater than is greater than or equal to 3. And the solution will be less than or equal to -3, greater than or equal to +3. You follow me? And the other one, same thing, greater than or equal to 3. Okay, so over here is going to be less than equal to, this will be greater than equal to, and the graph will, of course, will change slightly. Okay, so this is going to be a dot, and this is going to be a dot. And everybody knows the pictures. I know everybody knows the pictures. but you have to express it correctly. Okay, a lot of those professors at a four-year school or at El Camino, they do expect you to write these inequalities correctly, but yet our trouble in this area hopefully will end very soon. Will end very soon. Okay, is that helpful? Is that helpful, everybody? So now it's your turn. Okay, so we have greater than equal to, and next I want you guys to pick some questions. And this time I'm going to pick some questions for you. How about that? Okay, so please try these questions in 14A, alpha 14A. Okay, I want you to do number 3, number 4, number 7, number 8, okay? So this is absolute value of x larger than 0, and this other one will be larger than or equal to 0. And the next one, 7, 8, larger than square root of 2. And this other one is going to be less greater than or equal to square root of 2. Okay, just look at these questions, and I hope you to think about what we have done. Okay, greater than case, greater than equal to case, and solve these inequalities. Excuse me, I'm gonna wash my hands. I'll be right back. How's it going, guys? Do you want to show your answer to me? Would you like to show your answer to me? Okay, never mind. Okay. So we just look at the number line. Okay, let's look at number 3. Right? You can see, unlike the other one, right? Unlike the other one, we have okay, let's see. Just show me this number line. Okay, just this number line. That should do the trick. Okay, now we want the absolute value of x to be positive. Okay, so instead of larger than 3, now we like it to be positive. Positive. So how do we formulate our solutions? Can we still go by the same old way we did? Okay, positive or greater than 0, however you interpret it. Okay, so all of these are interpretations, right? We want the absolute value to be positive, right? So what will be the solution? Two perspective, from function perspective. Okay, the function perspective says, find me all the input such that the output is positive. Well, remember, what's the domain for this function? What's the domain for this function? All real numbers, right? Every number but 0. Every number but 0. Every number but 0 can make that happen. Okay, and all the other numbers are solutions. Do you agree? Because all the other inputs will make a positive output. Do you follow me? All the other number will make the output. So I'm gonna graph this. Okay, I'm gonna graph this. So you're gonna see the picture. Gonna see the red. And I want to show you on this side, on the other side. All the numbers on the number line, okay, those are the choices for input. Every one of this input except 0 will make the positive output. Okay, so what is our solution? The solution can be expressed in multiple ways. The simplest way is x is not 0. The interpretation of this notation, meaning, okay, meaning all real numbers but 0. Okay, you can just write this shorthand notation. Do you follow me? You can just write that shorthand notation. On this side, it's almost the same. It's almost the same. Just from number lines perspective, from the number lines perspective. Okay, so I'm going to put a -1, 0.01. Okay, wait. That's it. Number line. So the solution, x is not equal to 0. That's sufficient. That's sufficient. For number 3, that's the answer. Then you say, are there other forms of solution? Sure, you can use interval. You can use interval. Okay, you can use a word, but you can see x not equal to 0 is really the simplest way to express it. Okay, so I'm going to give you all these, I'm going to give you some other alternatives. They're fine. Okay, alternative solutions. Alternative solutions. Oops. This software, when they handle the change of mode, it has some interesting phenomena. Okay, so alternative solution. You can say, oh, from -infinity to 0, union 0 to +infinity. Okay, you can do that too if you want. Okay, you can also use word, but which one is my favorite? You want to know what's my favorite? This is my favorite. That clear, everybody? It's short, it's simple. No nonsense. No nonsense. So with that understanding for number 3, can you tell me what is your solution for number 4? 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 What is it? What's your solution for number 4? From greater than 0 to greater than or equal to 0. It's non-negative. Greater than or equal to 0. This time, what will be the solution? What will be the solution now? Should 0 be excluded this time? Should 0 be excluded this time? Should 0 be excluded this time? Huh? No, all real numbers. All real numbers are solutions, okay? Because the absolute value of any number is always greater than or equal to 0. So the solution would be from negative infinity to positive infinity. Okay, if you want to use words, that's not a problem. All real numbers. Okay, or if you prefer this, you know, in this case, if there's no inequality form, there's no inequality form for it. So either use your words and that's it. That's as good as anybody could expect. Okay, you either use words or you use interval. So the solution in this case is all real numbers, because all the output, no matter what the input, okay, no matter the what input. Remember when we talk about the domain and range for absolute value of x? What's the domain? Domain is all real numbers, and the range is exactly this. Okay, recall, I want to remind you, recall. Okay, we have made it this one sentence statement about absolute value. Any real number x. Right, so which is a consistent here. Okay, so number 6 we skipped. I want you to think about it. Okay, I think you should be able to figure out, but otherwise, if you still have questions, bring them back. Next, let's look at 7, 8. Okay, let's look at 7, 8. Let's look at 7, 8. Seven, 8. Larger than root 2, larger than or equal to square root of 2. In this case, really, the nature of the question is the same, greater than root 2. Okay, so which one of these situation will be fitting? Will be fitting this form. Okay, this form. Okay, the only thing you have to do, you have to do is change all the 3 to be square root of 2. Really, that's really all you need to do. Okay, shall we do that? So you can see the graph. Okay, you can see the graph. I'm going to put the root 2 there and put root 2 there. Just all the numbers are changed to root 2. Okay, let's change to root 2. Let's just change to root 2. We have any more. So I think that's it. That's it. It's changed to root 2. And of course, these negative, I will remove these other things. Okay, I'm going to remove those other things. -3. The label will just be slightly changed. Okay, so this is going to be negative root 2, SQRT2, and this other one will be SQRT2. And we may like to scoot over a little bit. So this is going to be -1, -1.5. No, this is going to be +1.5. And this is going to be -1.5. I'm just approximating the position. Okay, so this becomes square root of 2. And this number will turn into this guy. Okay, so do you guys see the process? I intentionally want to show you the process, okay? And from the process, you see similarity. You see similarity, don't you? Do you see the similarity? And so the x is y is going to be 2. Oh, that's it. So this line, this broken line is square root of 2. And these can be adjusted similarly. Okay, this is just square root, negative square root of 2, and this is positive square root of 2. And all of these will be changed to square root of 2. Do you see that? Do you guys see the similarity? Same idea. Okay, same idea. Whether you handle, whether you handle 3 or you handle square root of 2, the ideas are really the same. The idea is really the same. Okay, I can make some adjustment here. Okay, so let me see if I can make that adjustment. Do you guys follow me? So could you guys complete number 8? Could you guys complete number 8? Okay, so I'm going to put this over here. Let's see if I can make it a little faster process. This one. Okay. That. Okay. I'm going to delete another thing. Delete that. And I think we're fine. We're good now. And I just want to show the number line. I just want to show the number line. And negative 0.01, positive 0.01. Okay, I think that should be good. Yep, that works. Okay, just for the visual effect. Okay. So do you see the idea, right? You see the idea for greater than or equal to square root of 2 is similar. So I have mentioned the key point for doing this. I mentioned the key point and those are popular mistakes. These popular mistakes could be greater than or equal, and that happens too. Okay, so please don't make those mistakes. Okay, if you understand what we're talking about. So now greater than or equals to square root of 2. Okay, so everything can pretty much copy. Okay, they're so similar, right? Do you guys have any questions? Do you guys have any questions? And now I just need to change it to a dot. I just need to change it to a dot. Greater than or equal to, right? Greater than or equal to. You see, there's just little change, but the ideas, the meanings don't change. Okay, now I need to change this, all of these to be greater than equal to. And does everybody follow me? Am I going too fast? Am I going too fast? Does everybody follow? Because last thing I need to change the dots, right? So I need to make the dots change. So this is going to be a solid line, and this is going to be a dot instead of a circle, and this is going to be a dot instead of circle. See? When equal to is included, okay? And this other situation, and it's going to be changed to a dot. Wait, come on, guys. change to dot, change to dot. Whichever seem to be simple for you, whichever one is easier for you. But I do encourage you try to understand that, both are, both approach, both work. Okay, this way might be something you have learned before, and this is a new perspective from functions perspective. I want to introduce this perspective, okay, because we'll be using this later. All right, any questions? Greater than, equal to, greater than or equal to, okay? All right, so let's get to alpha 15. Alpha 15 gets more interesting, okay? Alpha 15 gets more interesting. Any questions so far? You must be tired by now. Yes, so let's look at alpha 15. So today we covered quite a lot of material, okay? So I think I will be probably giving you 2 more quizzes. I might be giving you 2 more quizzes as I'm thinking this week, or the written quiz this week, and let's not try to give you too many quizzes. How about I'm going to give you just 1 more quiz, okay? So you guys don't get so nervous. But based on this written quiz, I will be giving you another quiz, okay? I will see how you do. I will see how well you do. Okay, I expect amazing results. But in any case, we have issues, we deal with it. We deal with it, okay? So once again, for alpha 15, we have a similar scenario. Okay? One is, I'm going to bring up the similar scenario. To less than case, okay? Just forgive me, okay? I'm going to bring that. So I'm doing this because I want you to compare, okay? I want you to compare that scenario in your study and understand its meaning, okay? So this is what we did before. And now all of these is going to be changed to greater than or greater than equal to. Okay, so what will happen then? All of these need to be changed. All of these examples will change. Right? This is x minus 2 larger than 3. And this is x minus 3 larger than or equal larger than root 5. Right? So I'm going to remove all of these work we did before. Let's see what's going to happen now. Okay, so let me use, I'm creating a new examples, okay? I'm creating new examples. In this case, what is the solution? Omega is less than -3, or omega is larger than 3. Do you follow me? Right, because now we're greater than, right? We have all these contexts we talk about. And now for greater than or equal, what would it be? That would be less than or equal to, and this is going to be greater than equal to, this is less than equal to. Does everybody follow me? I know you might be a little bit tired, okay? You might be a little bit tired, okay? With that model, we created these. Other questions. How are we going to deal with them? The same way. And of course, this is larger than, sorry, this is larger than, okay, sorry about that. Larger than equal to, larger than equal to. The only difference is the numbers are different. And this bologna could be all kinds of different shapes and forms. And in this situation, what do we get? We have x minus 2. And in this other situation, we have x minus 3. Okay, so guess how we work it? This is how we work it, okay? I will show you a shorter version of final, shorter work if some of you guys care about it. So I basically will copy this model And I will change this to x minus 2. You follow me? And then I have two inequalities I have to solve separately, but knowing that they are connected by OR. Connected by OR. Okay, so from here, I will get x less than -1. And the OR still comes with me. And this x is going to be larger than 5. And that is the final answer. That is the final answer. Does everybody follow me? Okay. In this other one, same thing. Same thing. Understand the idea? So this omega now is x minus 3. I'm just creating these random examples, okay? So x minus 3. And then the next line, I'm going to solve these two inequalities respectively, but understanding they are connected by OR. So on this side, it's going to be x. Oh, sorry, I have a square root of 5, right? I have a negative square root of 5. Sorry about that. Negative square root of 5. Oh my God, I'm sorry. I was trying to finish this fast. So, and this is a square root of 5. Right, this is square root of 5. Okay. So then you're going to add a 3 on both sides. So add a 3 on both sides, you're going to get 3 minus square root of 5. Okay, you cannot simplify that. You don't simplify that. That's okay. And the other one, if we end up with x, okay, larger than or equal to 3 plus square root of 5. And you just leave it like that. You don't need to get the numerical value. You don't need to punch in the calculator to get, well, I want to get this one number. No, you don't need to. You don't need to. Okay, don't do it. Okay. You don't need to do that extra step to save you the trouble. And on top of that, your math professor will be most happy to see this instead of the decimal numbers. Do you follow me? Because we love precise numbers. I don't know what's wrong with us, but we love precise numbers. Any decimal number you're getting from your calculator, they're not going to be precise because square root of 5 is never going to be a precise number. The most precise number for square root of 5 is square root of 5. Okay, don't try to get that 2 point blah, 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 blah. We don't want that. We don't even want to see it. Got it? So save your trouble. Just solve these, and that should be your final answer, and that's mighty perfect. Okay, and this is perfect. Okay, so on your paper, how do you show your work? Right, I was telling you, I'm going to give you quizzes this week. I'm going to give you a written quiz this week. How do you solve this? Okay, the first step, you copy the question. The second step, you get this. Second line and third line. I'm going to tell you the point distribution, okay? You write it down nicely. You write it down nicely, the 3 lines. This line is going to worth 3 points. Okay, this line is going to worth 3 points. This piece counts as 1 point, or counts 1 point. X minus 2 greater than 3 counts 1 point. So 1, 2, 3, 3 points. If or is missing, we have discussed that, right? If or is missing, there's a series of consequences. Now, 2 points. Okay, 2 points. We're still attached. Okay, if you can just show this piece of work, I assure you, you're going to impress every professor in the math department in the future. You're going to get all the points. Do you follow me? Don't make those other mistakes. Don't make those other mistakes I pointed out. Okay, So let's just to make them complete. For solving this one, how do you show work? How do you show work for the next one? Okay, how do we show work for the next one? Well, this is going to be the second line. And this is going to be the third line. Okay, it's a bunch of if statement, if then statement. That's what we're doing here. Okay, if this is true, if this is true, then that. If this is true, then that. How many points you getting for this? 3 points. Again, no question asked. Okay, I will guarantee personally that I will be consistent with my rubrics that I set up for all the classes I teach. All the classes I teach, whether you take my intermediate algebra, you take my trigonometry, pre-calculus, calculus, and I'm consistent with these rubrics. Okay, total 5 points. Please, 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 please do not, because those other 4 mistakes make these mistakes. Okay, those other mistakes I pointed out, guess what? They will evolve. Okay, so I'm going to make another popular mistake just as a gentle reminder. Okay, and these mistakes will turn into what? Take this one, for example. Okay, solving that one. People might be doing x minus 2 less than 3 minus 2 greater than 3. I forgot the or. Or is missing. In this case, you still may get 0 point, you may get 2 points. I will have to determine from my reading your context. Okay, you can see it's more work for me. Okay, I will be very carefully to examine your context. So you may get 0 point, you may get 2 points. Okay, but if you put a 0, I'm sorry, if you put and you surely get 0 point. If you do this, okay, 0 point. If you do this, 0 point. So these are the popular mistakes I can think of that has registered in my mind for all these years. Okay, I always pointed out these common mistakes, these very popular mistakes. But just because they're popular, they don't make it right. Okay, I'm so sorry. I'm so sorry. So please commit yourself. Try to understand these different perspectives and how they're expressed mathematically. And if you have any questions, and I will be very, very happy to help you to understand this and to get over this. Okay, let me assure you, it's definitely worth your while. If you care about those points, if you care about your grades, it's definitely worth your while to get over this. I'm committed here for you. And are you committed for yourself? That's the question. That's the question. But I'm so happy that even though our class is fairly small, you guys has been persistent in attending. Okay, I hope I can be as much help as possible for you. Okay. So do you expect another written quiz? I'm not going to give you 2 more quizzes. I'm just going to give you 1 more quiz. And next week, there will be 2 more quizzes. We might be still working on these materials. Okay, but these materials, they may seem difficult, but these are the problems. These are the areas that we have the most, we have, one of the most issues from my career, my entire career of teaching. Okay, so do pay a bit more attention to these issues. Okay, as I pointed out. Okay, so when you do your written quiz, which will come up this later today, so please do, if necessary, watch the lecture all over again. Okay, I think the recording should be available soon in the afternoon. Okay, I think that's all for today. Do you have any questions? I'll still be hanging out here for, until 1 p.m. And if you have any questions, please feel free to stay. Excuse me. I will see you next week. Very good job. Thank you for coming. Okay, keep up with your good work. Okay, keep up with your good work.